We wouldn't say Newton's theory was wrong. It had very, very small corrections, incredibly small corrections. It's actually a puzzle why they're so small. So if you watch the precession of Mercury's perihelion, this was the first indication of something going wrong. According to Newton's theory, Mercury has an elliptical orbit. The long part of it moves around as other planets come by and perturb it and so on. And so this was measured by Leverrier in 1859, and he compared theory and experiment, and he found out that the perihelion precess moves around the sun once every 233 centuries instead of every 231 centuries. Okay, now this is the wonderful thing about science. Why was this guy? I mean, you don't have any idea how much work this is, But of course, he made one of the greatest discoveries in the history of science without, even knowing what good it was going to be.
Mm-hmm.
So that's how small that was the first sign that there was something wrong with Newton.
Yeah.
Now, so the corrections to Newton's law are very, very small, but they're definitely there. The corrections to electromagnetism, they're mostly, the ones that we see are mostly coming from quantum effects. And
so the corrections are for Maxwell's equations is when you get super tiny, and then the corrections for the for Newton's laws of gravity is when you get super big. That's when you require corrections.
That's true, but I would phrase it as saying when it's super accurate.